11.2 deals with outcomes of independent events. For working example number 1, we need to determine the total number of outcomes from 2 events. So Carrie flips a coin and rolls a 6-sided die. How many possible outcomes are there? Well, if we build a table, we can take the first experiment, which is a coin flip, and put it down the side of the chart. And the rolling a 6-sided die, that's the second experiment. That's going to go across the top. So on the coin flip, we have a possibility of heads or tails. And on the coin, or on the die, we've got options of 1, 2, 3, 4, 5, and 6. So those become the headings for your rows and columns. And then you can build the content based on what you see. So this top row is all heads. And the second row is all tails. And that's probably a good way to fill these out so you don't mess things up. Start with the rows, since that's the first item in your list, and heads all the way across, and then tails all the way across. Then go through and do your columns. These are all 1s, these are all 2s, this one is all 3s. Then we've got 4s, 5s, and then 6s. So in this case, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes. Each cell, so each square in the grid is a possible outcome. And we've got 12 of them in this case. So that's how many possible outcomes there are. The total number of possible outcomes is the possible outcomes on the die, or on the first experiment, multiplied by the possible outcomes on the coin, or the second experiment. So, number of possible outcomes on the die is 6. 1, 2, 3, 4, 5, and 6. And the possible outcomes on the coin is 2. It's heads or tails. So 6 times 2 is 12. So that's the other way to look at this, without actually building a chart to figure out how many outcomes there are. So there are 12 possible outcomes in this scenario where you're flipping a coin and rolling a die. So based on that information, see if you can do the show you know. Please go ahead and do it.